Hello friends, welcome to Shiksharthi. In this session, we are going to talk about Apollonius theorem. So let's start. Now in the very first place, we need to understand what is an Apollonius theorem. So Apollonius theorem is given rise to when we talk about the triangle and then we talk about the medians. So let me just draw the triangle for you. Okay, let me take a triangle. And then we talk about the medians of the given triangle. And then we talk about the point of intersection of the medians. And thereafter we are able to associate the length of the medians with the length of the sides. So there are some prerequisites for this session. The prerequisites are again those 4 prerequisites that I always talk about. You should know what are these terms. Which terms am I talking about? What is similarity? What is congruency? What is perpendicularity? And what is parallelism? And then the properties, theorems, proofs, axioms, etc. associated with all of these. So I have taken a triangle here wherein now I am labeling their vertices, and before I start the explanation of the same, we need to understand when we are talking about Apollonius theorem. The Apollonius theorem. What exactly is an Apollonius theorem? So which to some extent I have already clarified, but then what are the terms etc. that we are going to use here will decide what is an Apollonius theorem. So if I say that AD, CF and BE, we are talking about these line segments. It is given that these are medians. Now how do we say these are medians? You can say these are medians only when you say AF is equal to BF. In that case, you say that CF is the median, or let me write down in that specific order only in which we have written down the medians. So in that case, which is the first median that I have written? BD. So I'm sorry, AD. So in that case, AD becomes the median only when BD is equal to DC. So these are properties which are conversely associated with each other. So if I say AD is the median, then BD is equal to BC, and if BD is equal to BC, then AD is the median, is what I am trying to highlight. Okay, so if CF is the median, in that case AF needs to be equal to BF, and if AF is equal to BF, then CF is the median. If BE is the median, in that case AE, the line segment AE should be equal to the line segment EC, and if the line segment AE is equal to the line segment EC, and these all the things we are discussing with respect to the given triangle ABC, then BE is the median. Once you know this, let me use some representations here so that we are able to understand now. So these are the pictorial jargons that we are using in mathematics. What are the pictorial jargons? These two line segments are equal. Analogously, the line segment BF is equal to the line segment AF. Now why I have used 3 different colors here is to signify that, I mean, nowhere have we said that all 3 sides of a triangle are equal. So despite the fact that I'm using a kind of an equal to sign to represent that the line segments are equal, but I'm using a different color just to symbolize that none of the three sides are equal to each other. None of them are equal to each other. Please make a note of that. Okay, once we have done this, now what is next that we are supposed to do here? So let me drop a perpendicular. So when I drop a perpendicular, so let us say the perpendicular that I have dropped is from the point A onto the line segment BC, and the foot of the perpendicular is H. Now when all these things hold good, these things, they hold good, then we can say that G is the centroid. So these are the jargons, mathematical jargons that we are supposed to use in geometry. So what is centroid? The point G here is a centroid, which is the point of intersection of the three medians which can be drawn inside a triangle ABC. Okay. Now let us see further what we can do. Okay. So we have already done few things in other sessions of ours. And what are those things? So we have done something like how to find out whether a triangle is an acute angle triangle or an obtuse angle triangle. We have done cosine theorem, we have done sine theorem, etc. So we'll be using that entire discussion as a lemma for this session. So in that case, what are we going to use? So let's say that in the triangle ABD, we know that AH is a perpendicular which is a common perpendicular to the triangle ABH and AHD. So in triangle ABD, we can further divide this into two triangles, which is triangle ABH and the triangle AHD. So from here we can simply pick up the property. And what is the property that we are going to pick up? The property that we are going to pick up here is, can we say that AB whole square can be written as AD whole square plus, what is the next thing that we can write here? We can write plus BD whole square minus 2AD into BD. Have we done this property earlier? We had done this when we were talking about cosine theorem. We had done this when we talked about acute angle triangle theorem and the obtuse, how to find out whether a given triangle, with the help of sides, how to find out that the given triangle is an obtuse angle triangle. We had talked about this. Okay, so can we use this directly is the point that we need to understand here. So from the triangle ABD, can we say this? Yes, we can. Analogously, can we say from, so in triangle, so there are two triangles now further which can be made. So one is triangle ABD and the other triangle now is ADC. So can I say that the triangle ADC is an obtuse angle triangle and the triangle ABD is an acute angle triangle? And following this, now finally we can say that AC square can be written as AD square plus what is the other thing that we can write here? CD square plus, why are we writing plus? Because this is an obtuse angle triangle, plus twice of AD into CD. So let us say that this is what we had written as the first equation. This is the second equation. Now can we use this as a lemma? Now we can use this and we can say that 1 plus 2 makes it what? It makes it like AB whole square plus AC whole square can be written as twice of AD whole square plus CD or BD whole square. Now why are we saying CD or BD whole square? Because we know that BD is equal to, can we say BD is equal to CD? So when we had written here, we had to write this BD is equal to DC, not BC. So as a learner, when you're learning things, so many times what happens is we know certain things, but we err when we are writing. And you can see that as a learner myself, we may know certain things, but when we are writing, we may err. So when you're doing something, please keep on revising the things again so that any such mistake or error that you would have done can be identified by you easily, because the concepts are clear to you. The problem here is not with the concepts. The problem here is when you are writing something, you need to be further more attentive. Okay, once you have written this, now can I say that this is what Apollonius theorem is? Yes, this is one of the aspect of an Apollonius theorem which talks about how to find out the length of the median. And in this case, we are talking about the median AD. Now maths and logic should go hand in hand. So once you are able to find this out, it should become easier for you to find out the length of the other medians as well. So wherein we know that AB, if I combine the square of the sides AB and BC, in that case what are we going to get? We are going to get the lengths of, we are going to get the length of the median BE and last but not the least, you can find out combining the square of the sides, the remaining two sides, so is AC and BC. From here you can find out the length of the third median, which incidentally here is CF. So now we can use a different color for them just to symbolize that these are the three different median lengths that you can calculate inside a triangle, which incidentally we took it as a scalene triangle. Now you can take your learnings to the next level, and what is the take home that you should take from here is, what if I want to draw a synergy between the sides and the medians of the same triangle? So we will do a separate session on this.